Yo, 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 yo. Hey, everyone. Here we go. Getting to topic 6, which is going to be all about exponents. And let's just get right to it. So, an exponential growth and exponential functions, but we're going to talk about properties of exponents today. So first we want to talk about is rational exponents, which is another way to express radicals. That's what we're going to start off with. So a rational exponent is when we have an exponent that's like a fraction. So it'd be like 8 to the power of 1/3. That's a rational exponent. Okay. And then we're also going to talk about product of powers. That is a review of one of our properties of exponents. And product of powers is when we are multiplying two terms with the same base, we add the exponent. So that is when if I had like a to the 4th power and I'm multiplying that by a to the 6th power, well, this is where this is really just equal to a to the 4th plus 6, which is the 10th power. Okay, they have the same base, we just add the exponents up because I have 4 a's, 6 a's all being multiplied, so really I'm multiplying 10 a's all together. So this is just an example of the product of powers. Now, first what we're going to do is we're going to look at how we can write radicals using rational exponents and then also write rational exponents from radicals. So we want to figure out what does 3 to the power of 1/2 really equal. So this is 3 raised to the power of 1/2. And here's our formula that we use to rewrite it as actually a radical. So 3 to the power of 1/2, the numerator always goes as the power raised is the power that the base is being raised to. And then we put a radical there and we take the denominator and put it on the outside. So 3 to the power of 1/2, this 1 goes on the inside. So it's 3 to the power of 1. And that is all being taking the radical or the square root. 3 to the power of 1 is just 3. So really what this is, 3 to the 1/2 is just equal to the square root of 3. Okay, because 3 to the power of 1 is 1. If I have a 2 on the outside, that's asking me for the square root. Okay, and so because it's what number times itself twice, and that's just a radical without even the number 2 there, so we don't even need that number 2. So another way to write the square root of 3 is 3 to the power of 1/2. These are equivalent to one another. So square root of 3 is equal to 3 to the power of 1/2. Now the reason why we would do this and rewrite these in different ways is to help us solve equations. Okay, because sometimes writing a radical might help us solve an equation, but sometimes going from a radical to an exponent would be very beneficial for solving an equation. So using that same formula, we want to write a radical using a rational exponent, and we also want to write a rational exponent from a radical. So again, the top just goes inside, so that becomes 5 squared, and this is going to be the cube root because the denominator is 3. Okay, you can also then rewrite this if you wanted to as this. These are the same thing. Okay, so these would both be acceptable answers. You could also just write it as a cube root of 25. All three of these are the same. Now over here, we're going backwards. So the number on the outside, it's asking for the 5th root. So that becomes my denominator, that becomes my numerator. So that's the 7 to the 3/5. And again, the only reason why we're doing this is showing you equivalent expressions so that we can rewrite them to help us solving equations. Now, what you're going to be doing is you're going to be solving equations that look like this with rational exponents. So here I have 3 to the power of x minus x over 2 times 3 to the power of x over 3 equals 3 to the 9th. So what we're going to do is we're going to use our product of power. So I know I have the same base. They both have a base of 3. So when I multiply two numbers with the same base, we just add the exponents. So this is really going to be 3 to the x over 2 plus x over 3. And that's all equal to, oh, my pen stopped working. There we go. That was weird. And that's all going to be equal to 3 to the power of 9. Because this is being multiplied, I just add the exponents, and I keep the base, just like what we talked about in the beginning. Well, what I need to do is I need to be able to simplify this part right here, because this has the same base, I need to make this equal to 9. So really my equation is x over 2 plus x over 3 is equal to 9. Because if this was equal to 9, these would be identical. So here's my equation. I need this to all equal 9, because that's what the left side and the right side would be equal to each other. Well, I don't have a common denominator here. And when we want to add fractions, I have 2 fractions, I have to have a common denominator. So, well, I'm going to multiply this 1 by 3 over 3. I'm going to multiply this 1 by 2 over 2. So I'm multiplying them by 1, so I'm not changing the value. So that's going to become 3x over 6 plus 2x over 6. And all that's still equal to 9. Well, now when I have a common denominator, you just keep that denominator, add them up. So I get 5x over 6 equals 9, and now I have a simple equation to solve. If I wanted to get rid of that denominator divided by 6, I can multiply by 6 on both sides. Those cancel. I'm just going to go over here. So I'm left with the 5x equals 54, because 9 times 6 is 54, divided by 5, and I get x equals, let's see, that's going to be 10.8. Or you can leave it as 54 over 5, or 10 4/5. Okay. And that's it. Okay, so I solved for x. And the way I did that, I used my product of powers. I added my exponents together, and then when I did that, when I had the same base, I knew that this had to be equal to 9, so now I had to figure out what value of x would make this equal to 9. Okay. Try this one on your own. It's the same process. We have the same base. See how you do. So again, I'm multiplying the same base, base of 8 equal to base of 8. So I'm just going to add the exponents. So this is negative x over 2 plus negative x over 3. The negatives don't change anything. Is equal to a to the negative 2. So this right here has to be equivalent to negative 2. Oh, there's my equation. X over 2 plus negative x over 3 should be equal to negative 2. Again, 2 and 3, I need a common denominator, so I'm going to multiply this whole side by 3 over 3. That's going to give me negative 3x over 6. And I got to multiply this by 2, so it's going to give me negative 2x over 6 as well. Because it's plus a negative, I'm just going to make it a minus sign. I can actually add these together now. Negative 3x minus 2x is negative 5x over 6, which is equal to negative 2. I can multiply both sides by 6 to make those go away. I get negative 5x equals negative 12 divided by negative 5, and I would get 12/5. It's a positive because negative divided by negative is positive, or I can also just get 2.4. Okay, and I'm done. All right, last one to try on your own, I believe. Yeah, last one to try on your own. See how you do. Definitely pause it, try it, see what happens. Okay, so I have rational exponents, same base. So I'm going to add my exponents together. So that's x to the 4th plus x to the 6th equals 2 to the 3rd. So I have x over 4 plus x over 6 equals 3. Common denominator is going to be 12. So I'm going to multiply this one by 3 to get 3x over 12. Now, if you didn't use 12, if you use 24, it's fine. It doesn't make a difference because when you simplify it, it's all going to look the same. I'm going to multiply this one by 2 over 2. So that's 2x over 12 And that's equal to 3. Add these up. Let's see, I'll get 5x over 12 equals 3. I'm going to multiply both sides by 12. 5x equals 36. So now that I have 5x equals to 36, I can just divide by 5. That's going to give me, let's see, 7 1/5, which is 7.2. Okay. Hopefully you got that one right. So that's really it. That's all I got for you guys today. So independent practice, make sure you get that done. Things to remember. For things to remember, I want you guys just to show an example of a power, but let's do a simple one. So 4 to the 3rd times 4 to the 5th equals 4 to the 3 plus 5, which is 4 to the 8th. Not 8, but 4 to the 8th. So yeah, get an example of that in there. That'd be great. And that's it. So I hope this video helped you guys. If you guys have any questions, please don't hesitate to ask. That's all I got for you today. Good to see you out.